For the last lesson for quadratic equations, we're going to look at the quadratic formula and the nature of the roots. So if I have the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, the discriminant is the quantity under the square root sign, or the radicand, in the quadratic formula. This value discriminates between the three different types of solutions that we can have. So this discriminant is just what's in here, or the b squared minus 4ac. If that radicand, or discriminant, is greater than 0, it's going to have two distinct real roots, which means that I have two roots that are of different values. If it is equal to 0, well, the positive square root of 0 and the negative square root of 0 are the same thing, which means that I'm going to have two roots still, positive 0 or negative 0, but they're going to be two equal roots, which is a fancy way of saying one solution. This would be the same if I had a factored form of x plus 2 times x plus 2 is equal to 0. Even though I have two factors, both factors are going to equate to the same thing. They're both going to equal negative 2. If it is less than 0, I can't take the square root of a negative number, which means that it's going to be no real roots. So, when I'm looking at the possibilities, if I'm given the roots of a quadratic equation, describe the nature of the roots. Well, here I have 3 or negative 4. These are 2. They're different values, distinct, and they're real numbers, real roots. In the second case, I have positive or negative 2 root 5. Well, positive 2 root 5 and negative 2 root 5 are two independent numbers, so these are also two distinct real roots. For example, C, it just says x is equal to 6. Just like what we had up here, I have two equal real roots. Two roots of the same value. For example, D, it says negative 3 plus or minus square root of 5 over 2. Well, either it's going to be plus root 5 over 2 or minus root 5 over 2. That's going to give me two different values. This is going to be two distinct real roots. And the last example, 2 plus or minus the square root of negative 3 over 6. I can't take the square root of a negative. This is no real roots. So, if I need to actually solve it for myself, and it wants us to state the nature of the roots, then the first thing I'm going to do is I'm going to put it in general form. 9x squared minus 30x plus 25 is equal to 0. This one is already in general form, and this last one I'd have to multiply it out and then move it to the left. This is going to be 4x squared minus 20x plus 25 is equal to 0. Then I'm going to take my a, my b, and my c values and substitute them into the discriminant. That's a, that's b, that's c. There's a, there's b, there's c, and there's a, b, and c. So if I'm just using the discriminant formula, then I'm going to say that in the first case, it's going to be negative 30 squared minus 4 times 9 times 25. And when I solve that, I get 0. Well, if that equals to 0, then I'm going to have two equal real roots. It's not positive, so they're not distinct. It's not negative, so it's not no real roots. In the second case, 3 squared minus 4 times 2 times 5 is going to give me negative 31. Because it's a negative number, there are no real roots. And for the last example, if I have negative 20 squared minus 4 times 25, this also actually adds up to 0. So I have, once again, 2 equal real roots. Now, if I'm determining the values of m such that this equation has either 2 distinct real roots or no real roots. Well, first thing, this isn't in general form. I would say that mx squared plus 4x minus 3 is equal to 0. There's my a, there's my b, and there's my c. To have 2 distinct real roots, it needs to be bigger than 0. So I know that b squared minus 4ac has to be bigger than 0 if this is true. So I'm going to substitute my values. 4 squared minus 4 times m times negative 3 has to be greater than, greater than 0. This is going to give me 16. Negative 4 times negative 3 is going to give me positive 12. M is greater than 0, and then I just have to solve for m. 12m has to be greater than negative 16, or m has to be greater than negative 16 over 12, which is the same as m is greater than negative 4 over 3. So any value where m is greater than negative 4 over 3, there's going to be 2 distinct real roots. If I want no real roots, I would do the same process, but I would just flip it. I would say that b squared minus 4ac would have to be less than 0. Or in this case, m would have to be less than negative 4 over 3. If I wanted 2 equal roots, then m would have to be exactly equal to negative 4 over 3. If I want the values of k that will give 2 equal roots, then I'm going to use the same process. I'm going to say that to have 2 equal roots, it has to exactly be equal to 0. So if b squared minus 4ac has to be equal to 0, this is my a, this is my b, this is my c, then that means that k squared minus 4 times 16 times 25 has to equal 0. K squared minus 1600 has to equal 0. So k squared is going to equal 1600. And remember, when I take the square root of both sides, I got to take the positive and negative square root. Or positive or negative 40. So k could either be positive 40 or negative 40. It's still going to give me exactly one solution, or 2 equal roots. And last but not least, if we put this into a word problem, A1 Sporting Goods Store sells 90 ski jackets in a season for $200 each. Each $10 decrease in the price would result in 5 more jackets being sold. Well, if my revenue is equal to the price per unit multiplied by the number of units sold, and it says that I'm going to do $10 decreases, so I'm taking away 10x from the price, and I'm going to add 5x to the number that I sell. Here's my price, and here's my units sold. And then I'm just going to put that into general form. R is equal to negative 50x squared plus 100x plus 18,000. If it wants us to find the number of jackets sold to give this revenue, then when you're doing it, try a couple of different methods. I'm just going to show you here on the factoring method. I would say that the revenue 17,600 is equal to negative 50x squared plus 100x plus 18,000. 0 is going to equal negative 50 x squared plus 100x plus 400. And then I'm going to start by dividing everything by negative 50. Which means that 0 is going to equal x squared minus 2x minus 8. Where 0 is going to equal x minus 4 times x plus 2. X minus 4 is equal to 0, so x would equal 4. X plus 2 is equal to 0, so x would equal negative 2. So there's two possibilities here, if he increases the price or he decreases the price. So this is just telling me how many changes. I'd still need to go back and say, well, how many units would this be? So I have to say 90 plus 5x. Well, in one case, 90 plus 5x, which is 4, is going to give me 110. In the other case, 90 plus 5 times negative 2 is going to give me 80. They would sell 110 jackets at $160, or 80 jackets at $220. Both of these would give me the same answer.